Welcome back. This is the second part of the lecture number 2. So, we have been discussing about how you discover materials, right, and I told you so much thing about serendipitous discovery of materials. Serendipity means accident, please remember. Serendipity comes from very interesting aspects. I can give 1 hour lecture on that, let us not talk about it, but serendipity means accident. Something happens in an accident which you do not want to happen. Nobody wants to have an accident, but it happens and then you discover something. But in the world of AI, rarely serendipity will happen. That is what we are going to see. So, let us talk about it. What is the new paradigm, discovery paradigm? Thanks to AI and ML, what can happen? So, first, before 1600, why do you call 1600? Because that is the time of Isaac Newton. The paradigm was empirical. Empirical means we know some connections, relationship between variables and something, but they are all empirical, not based on scientific thoughts. One example is rate of reaction. People knew rate of reaction formulas much before, but nobody knew how these formulas are derived. So, they are like a empirical science. Then between 1600, that is why the Isaac Newton came into picture. 1600 and 1950, as late as 1950, almost 350 years, what do you have a second paradigm? That is why you have model and theoretical science. A lot of development happened in thermodynamics, kinetics, many subjects, especially in material science, thermodynamics and kinetics were developed extensively in this 300 years time period, or rather I would say mostly 1700 to 1950, and that is why we call a second paradigm. This is a second paradigm, you can see here, second paradigm is listed here, and there models are available. We know the theoretical understanding of subject, but we did not have computers. The first computer actually was made in 1940 sometime, I do not remember, by IBM. That was a very small effort, it cannot do much calculations in those days. But then came the explosion from 1950s to 2000. What is that? That is the time we started understanding that any material performance or property depends on structure, and structure depends on processing. How do you make it? So, when you make a material, you create certain kind of a microstructure or structure. It can be connected to atomic structure also. You can understand that using characterization, and this structure will give you the proper properties. Remember, we are talking about discovering material with target properties. So, that is what is your aim, but remember, property is not the extreme thing. What is extreme important thing is the performance of the device where this material is going to be used. In a mobile phone you have a display, and display is done by liquid crystal display or TFT or whatever it is. There are many things available in this today's. LED is also available. We have display by QLEDs also. So, does not matter, but you have to see it properly, or whether your pictures, videos, everything should be seen properly. That is the performance, that is what you want. Performance is basically for a device, and device is made of many materials. Each material has specific properties. That is the difference between performance and properties. So, that is what came in picture in after 1950s. So, therefore, 1950s and on we have a third paradigm, that is what people call as a simulation paradigm or computational science paradigm. Okay, we have the densely functional theories and molecular dynamics theories available in the material science, physics, condensed matter physics community, and that is what given us completely new way of looking at things. So, if I go back starting from empirical to model based to computational aspects, what is the change happened? What do you think? Well, only certain things change happen. Obviously, between empirical and model based, a lot of science has been added, very clear, because in empirical paradigm we did not know anything about what is happening scientifically. We knew some relationships, just like algebraic equations, but we did not know what is the origin of these algebraic equations. Remember, if I have an algebraic equation, let us say you have algebraic equation, if I have algebraic equation y is equal to f of x1, x2, x3 dot 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 something like this, So, that means what? X 1, X 2, X 3 are variables, y is a target. So, values of x 1, x 2, x 3 will determine the values of y. So, this empirical relationship did tell us that this y is dependent on these 3 variables. So, we knew that the factors on which y is dependent on, but we did not know what is the exact relationship. We have some empirical relationships. That is the difference between first and second paradigm. Second paradigm actually was completely scientific based, everything was science. That is why even in 1900 quantum mechanics came into picture. We have a lot of new understanding of the subject of thermodynamics came into picture. We know thermodynamics from equilibrium to non-equilibrium thermodynamics, all kinds of things you can talk about it, and many other aspects in material science happened. Physical metallurgy also underwent a lot of changes. Dislocations were discovered in understanding the deformation way of materials, and then you have all kinds of quantum effects came into picture. Nanomaterials came in picture in later part of 70s or 80s. So, therefore, we have a huge change from first to second paradigm. But can you use this scientific concept now thanks to development in computers? Computers mean speed and the power of computers. Can you develop new paradigm? That is what we are talking about, a computational science or computational simulation type of paradigm, in which we can actually simulate structures. So, we can simulate even atomic level configuration, electronic energy levels we can also simulate and develop from very basic understanding what is happening in the atomic scale. Can it percolate to the higher dimensions, from atoms to molecules to structure or microstructure, grains? Can it percolate that? That came into picture, and that is why it is called a computational paradigm. But you remember, there is another paradigm which I am missing here. What is that? Let me talk about it a little later. But with this computational paradigm, if I ask to accelerate the material science discovery, how will you do it? Tell me. You have any idea? Well, this is done by using obviously AI tools or AI driven tools. This picture tells you there are 6 levels, level 0 to level 5. What are these? What is level 0? Level 0 is completely human driven, correct? So, what is level 0? Level 0 is a typical human centric experimental process, and it is what happens till today in many laboratories. Students doing some experiments, getting some results. I will say researchers, actually research scholars doing some experiment, getting some results, and majority of the experimentation is carried out by human. So, some pieces of equipments can be used, even you can use computers also, provide signals to digital formats, but there is essentially no exchange of information other than what is measured and processed by human. No exchange of information between machine and human. Equipments are used to generate data, then data are used by human to create some kind of understanding. That is the level 0, that is the base level. You can see as human centric, we do documentation, then human look at the data, analyze the data to find out some correlation. Then little bit above is level 1, okay, that is the level 1 you can see here. So, level 1 basically tells you what? Assisted level. It is still human centric or human driven, but some amount of AI came into picture. What is it? This sees the implementation of some type of assistance, as Robert Black and Isaac Tamblyn has written in this book Accelerated Material Discovery. Some kind of a assistance to the human task, whether physical or digital does not matter, it can be both. Assistance is minimal and it is confined only to some kind of a single task, not multitasking abilities, as the case of pipetting machine or some form of a automated data collection like that. Automated data collection can be done by a CNC machine or many other machine also. At this stage, one can expect only human intervention, because you are collecting data, you are not doing much. So, that is what it is. Its accelerating factor for experiment is to increase what? It will increase, but it will increase very less. Then comes the level 2, which is called partial automation. What is it? At this stage, experiments workflow is becoming much more automated. That is what it is. So, you have automated many things. You can actually do an experiment in absence of you. You can set it up, an experiment will be done and data will be collected. And with various experimental procedures capable of operating over extended period of time, automated ones. This is called considered as a high throughput experimentations. That is what we call it, high throughput experimentation in this today's world. High throughput means you generate a lot of data in small, high throughput experimentation, you generate a lot of data in small time. If human carries out these experiments, it will take long time. That is why we are talking about trial and error. Here it is not the case. Here we have automated some part of it, so the data generation is faster and experiments are very quick. So, that is called high throughput experimentation stage. And obviously, workflow pace will increase quite a lot. While the workflow is in quite a lot of increased, incorporation of physical or digital means are very important. The human is still in control of the whole thing. Human has not gone. You can see here human intervention is still there. So, we have to go little bit further, that is called level 3. What is level 3? Level 3 is basically conditional automation, very interesting name, conditional automation. Automation means you automated it, but it is a conditional things. So, what is it actually? This stage sees application of AI/ML. So, in stage 3 only you are started using AI/ML. That is what you are analyzing your data using all kinds of machine learning algorithms or models. And we can create optimization loops which are coupled to the platform automation. So, we can use statistical tools and deep learning algorithms if you want into the workflow. A system will be capable to make its own decision. So, 0 to 2 system was not making own decision, human were making decisions, but here system will be capable to do some kind of a decision making process and based on the whatever data available. So, this can be considered actually best level for self learning. So, you can write down at this as a best level for self learning, best level for self learning. Machines will start learning at this level, level 3, and that is why this is we call starting point of using AI. So, it took 3 levels to achieve that, that is what it is. Now, but still knowledge is still a key to successful, it drive the experiments effectively. So, therefore, human is required, it cannot be completely decoupled, but human intervention is less, because machine is doing some calculation or modeling to get some kind of a sophistication, that is what it is. So, please remember this is called conditional automation. It is automation is there, but it is automated, but it is conditionally automated. Now, come the level 4 thing, which is very interesting. It is called partial autonomy. Why it is called a partial autonomy? Let us see. Well, at this stage system starts to truly become autonomous as it begins to infer properties and relationship from outside sources like literature, past experiments. It is trying to build that. Okay. So, it begins to infer properties of the system and then find out relationship from outside sources like literature, past experiments. Why? To truly plan and execute autonomous experimentations. If you want to do experiment in space, that is what you should do, human will not be there. So, there partial autonomy is very useful. Coupling theory and empirical data will allow the system to understand and infer chemical processes using knowledge to more effectively search the material landscape. Human role is very limited, that is what you see, human role is very limited. So, now comes the last stage or last level, that is called the full autonomy or level 5. What is it? This includes a truly autonomous researcher, where human can effectively be removed from the system. Some people say this is the bang. If that happens, AI will take over and then human like us will have no role in this world. And that is not it happened, that thanks to the literature, human can effectively remove from this picture platform is able to complete all tasks of discovery or reporting, and it determines what experiments, what simulation, what theoretical approaches need to be applied to optimize even active learning process. So, it can use its own thought process to do that. That is what it is. And furthermore, the stage is also represents a truly autonomous researcher. So, that is called true autonomy. So, true autonomy. And it can actually do all kinds of things. So, we want to achieve that. Final goal for human to achieve that is completely AI driven, even the properties interference, full system control, everything is AI driven, they will do it. But this is the required paradigm shift. So, that is what I bought this. Before I telling you the last paradigm, fourth paradigm, I want to show you this. So, therefore, from level 0 to level 4, we already have discussed a lot of things. Some part of things we have already discussed previously. Level 0 is basically trial and error. Level 1, some kind of a these things which are like using intuition like things. Level 2 maybe much better intuitions, but serendipity will somewhere come into picture. Serendipity is only for accidents, people who can accommodate accidents in their life, for them it is important. So, therefore, what it follows is that role of laboratory automation, machine learning, data infrastructure will play a very important role in to achieve this true autonomical pictures in this world, and that is something which we will learn in this course. I hope you can read more about this from this chapter in the book called Accelerated Material Discovery, and this chapter was written by Robert Black and Isaac Tumlin, and please read properly. Before we talk even more about this last paradigm, which is basically hint to you, typically how do you traditionally screen materials? I have given you some example. Suppose you are using, you want to you want to search a material for wire or basically transmission line, high tension transmission line, or you want to choose heat sink. Typically, if you do not have anything with you, how to search? First you select few new candidates, and then you synthesize that, analyze that, test it, and then screen for adverse, screens for which are not working, and then take those which are another possible set, again do the experiment. That is what is called traditional material discovery paradigm. So, this requires you to do so many things, time consuming aspects, which is may be costly also. So, instead of that, can you do virtual screening? Well, that is what it is. So, I have given you this traditional screening already, and then I am giving you new paradigm called computational material science. So, what do you do? You select a new candidate, you screen in the first case. That is what you do. We add a screening parameter here by machine learning or by automation AI tool. That is what you do, and this will go on, this loop will go on, and then it will give you some choices which are likely to be successful. Based on those some choices, use your intuition and synthesize those materials, and after that analyze and then test for effectiveness. You are bound to get a success, I can tell you. So, that is what it is. So, therefore, what is happening here is this, in this chart we can show it. Initially you have lot of choice. So, by using automation or AI/ML approach or computational material science approach, whatever it is you can talk about it, you can reduce the number of choices, so that you need to only prepare few materials, synthesize few materials. So, time is saved, energy is saved, cost is saved, and from this you analyze and then find the effectiveness and find out the right one. That is what it is. Okay. So, this kind of things are very common today. So, therefore, it is from Edisonian to high throughput to target design approach. That is what I talked about in the last slide. This is called target design approach. Okay. Target design. That is what we talk. So, in case of Edisonian approach, you are going to only do hit and trial. You have no idea what you are doing, you try it, find out If it works, it is fine. If it does not work, you change it. High throughput experimentation, what did I told you? You can actually, you remember, let me go back. This is what high throughput experimentation is in the level 2, the partial automation. You can fit as many gadgets as possible to your experimental setup and get data, faster experimentation, lot of data availability. That is what is high throughput experimentation, that will make you things faster, but will it allow you to go to target design approach? No, answer is no. In order to achieve the target design, you need to do something else. That means you want to achieve a targeted property for a particular material synthesis. But on the top of which you have another thing to be added, that is the manufacturing attributes. I can make a material small quantity in lab, but when you want to make large piece or in large numbers, in order to manufacture and sell, I have something else to be taken care of. So, I have to talk about product attributes like density, hardness, toughness, many other things, and as well as manufacturing ability like viscosity, glass transition temperature, liquidus temperature, cost, CO2 emissions, many things, environmental impact, all these must be taken care of. So, these attributes are never considered when you are designing a material or discovering material in the lab. So, that is why if you want to have glass, you want to have a glass material, you want to design new glass compositions, you see there are about 10 to the 52 possible glass composition available, and only 400,000 glass compositions are explored over the last 6,000 years. So, that is 10 to the power 52 is similar to number of stars in our Milky Way galaxy, and we cannot explore it, it is impossible, that is a massive number. So, last 6,000 years you only explored 400,000. So, that is 4 into 10 to the power 5, 10 to the power 52 is much higher. So, therefore, you have to use what is a principle called optimization principle, and that is why it is required. So, I will talk about more of this later, but let me talk about this slide, which is the last slide for today's lecture. So, we have talked about empirical science in the first paradigm, second paradigm was model based theoretical science, third paradigm is a computational material science, computational science or simulations, fourth one is basically the data driven science or is basically big data paradigm. You must have been hearing these aspects quite a lot. So, whenever you purchase something online store, that is stored in the database. So, next time if you browse the same online store, they know what are your choices. That is what is the use of big data is. So, big data uses all kinds of machine learning models to predict. So, from 2000 onwards, from 1950 to 2000 it was computational material science, 2000 onwards we have what is known as a big data driven approach or fourth paradigm. I do not know whether we have some more exist or not, that fifth paradigm or there or not, that will time will tell, but at least we are into the fourth paradigm of our scientific or new material discovery. So, now upon knowing all these aspects, you must be understanding that how do I know the fourth paradigm without knowing the third paradigm so well. Many of you may not have a complete picture of computational science or simulations, many of you may be experimentalists, do not worry, you do not need to know about it. Computational science is more like use of these equations in a computer to solve something, but data paradigm is different, use data to predict something. So, they are connected, but they are not so much dependent on each other that you cannot learn fourth paradigm without knowing much about third paradigm. That is my advice to you. So, please do not worry about it, many of the things will be connected to each other, I will make sure it happens, so that you learn all these aspects. So, with this let us stop the second lecture. I hope you have understood many of these aspects. In the next lecture I will also do some recap, so that these concepts will be much clearer to you. Thank you.